Hey, very good morning, students. Let us look into our next topic, 8-bit data multiplication. So I need to multiply two numbers stored in 9000 and 9001. The product should be written in 9002. If by chance I get a carry, that should be shown in 9003. So if I want to multiply 4 into 2, 4 is a multiplicand, 2 is a multiplier. 4 into 2, 4 is called as multiplicand, 2 is called as multiplier. What is my aim? To perform multiplication of two 8-bit numbers. So I need to multiply 4 into 2. I need to get a product called 8. So what is the syntax? In 9000 location, I am storing what? Multiplier. What is my multiplier? 0, 2. I am storing in which location? 9000. In 9001, I am storing my multiplicand. What is my multiplicand? 0, 4. Okay. And I want my product to be 9002. In 9002, I need to get my output product. Okay. So how am I going to do it? Through a program. For addition and subtraction, you have instructions like add and sub, but there is no instruction for multiplication. You cannot multiply two bits directly with help of an instruction in 8085. So how am I going to do the multiplication? I need to do it through addition. So if I want to multiply 4 into 2, what is the basic primary school topic of multiplication? If I want to multiply 4 into 2, what is that I do? I add 4 2 times so that I get 8. The same thing we are going to do it. So we are going to add multiplicand, multiplier times 0 plus 4, 4, 4 plus 4, 8. So this is what we say. Add multiplicand, how many times? Multiplier times. So I am adding how many times? 2 times. First 0 plus 4, 4. 4 plus 4, 8. Let us see the program how to do this. So I stored my multiplier in 9000, multiplicand in 9001. I need to get the product in 9002. So to do that, first I need to load register pair immediately. What register pair? HL with my first data. What is my first data sitting in 9000? So I write load register pair immediately. HL register with 9000. So immediately HL register will be loaded with what value? 9000. Then content pointed by HL. Can you see what is the content pointed by HL? Or memory location pointed by HL or addressed by HL will be in M. This is a very, very, very important statement. M refers to memory location. M refers to memory location addressed by HL. So M refers to what? Memory location addressed by HL. If HL is 9000, what is the value of M? 02. So what is the instruction I've written? Load register pair immediately HL with 9000. So when I write this instruction and execute it, what happens? HL will become 9000. Immediately your memory location will become 02. M refers to memory location addressed by HL. So M value will become 02. What is the next step? Move the value of M to B. So B value is equal to what? 02. What is the value of M? M is 2. That is moved to B. It means I have stored the multiplier 02 in a register called B. Done? Now what I am doing? Incrementing the register pair H. Previously HL was 9000. If I increment it, what happens? My HL becomes 9001. So what is that it means? When HL is 9001, M refers to the memory location pointed by HL. So what is M value? 04. So 04 is my multiplicand that is stored in M. Can you see? 04 is a multiplicand which is stored in M. Now what is that I need to do? I need to perform multiplication. To perform multiplication, I need to do what? Repeated addition. So how is that I am going to do? First I am going to add 0 with 4. Then 4 with 4. First I need to add 0 with 4. So Move immediately A 0 0. I'm clearing A 0 0. So my A is ready with 0 0. What is the next step? Move immediately C 0 0. By chance if there is any carry in addition, that has to be loaded in C register. So I am making C value as what? 0 0. Now what is ready? My A value is ready with 0 0. My multiplicand is ready. Multiplicand is ready with just 0 4. My multiplier is sitting in which register? B register, which is 0 2. Now what I am going to do? I am going to do my first step. What is my first step? Add A with M. Right? So what is that I do? Add M. So if I write this instruction, what happens? A is added with M. Answer is stored in A. So what is my A? A is 0 0. What is my M? My multiplicand, which is 0 4. If I perform addition of the 0 plus 4 is 4. That is stored in A. Have I done this first row? Yes. Where is my answer? 4. 4 is in which register? A register. 4 is in A register. I have done for first time. Have I yielded a carry? 0 plus 4 is 4. Is there any carry? No. Jump if there is no carry. Since there is no carry, I need to jump to which location? Next. So I am jumping here. What is my first instruction here? Decrement B. It means B is a multiplier. If I decrement B, initially B was what? Multiplier was what? 2. If I decrement this, it becomes what? 1. Indicating I have added 1 time. Okay. Okay. Now jump if there is no 0. Since B is 0 1, it is non-zero. Jump if it is not 0 to which location? L1. What is L1? Add M. What is add M? A is added with M. Answer is stored in A. What is current A? Current A is what? 0 4. So A is 0 4 added with M. M is what? M is 0 4. 0 4 plus 0 4, I get 0 8, which is stored in which register? A. 0 4 plus 0 4, I get 8, which is stored in which register? A. Have I done my second step? Have I yielded a carry? No. 4 plus 4, 8. There is no carry. Since there is no carry, I have to go to next. What is next? Decrement B. B is 1. If I decrement, it becomes what? 0. Since it is not 0, I need to go here. Since it is 0, instead of going there, what I do? I go to the next step. Clear? It indicates I have added how many times? 2 times. By decrementing B, I get what? 0. Since it is 0, I go to the next step. What is my next step? Increment register pair HL. Now HL, previously it was 9001. Now I have incremented it. It becomes 9002. This is the place I need to write the product. Yes, so what is this location says? 9002 means what? M refers to the memory location pointed by HL. HL is pointing 9002. Whatever value I write in M will sit in the memory location pointed by HL. So where is my product? Product is sitting in register A. My final product is sitting in register A. I need to move that product in A to M so that M sits in a location pointed by HL. So in 9002, I get what? 8. Increment HL. Again from 9002, it becomes 9003. In 9003, what is that I need to store? Carry. So carry is pointed in which register? Carry is pointed in C register. Since there is no carry, I move that carry from C to M because there is a relation. M is a memory location addressed by what? HL. So if HL is 9003, whatever content we move to M will go and sit and run and sit in which location? 9003. Stop the program. RST5 means stop the program. This is how you need to run the. Either you can write RST5 or write HLT, halt. Okay. So this is how you do the multiplication. Your first data must be, your first data multiplier must be in B. Your second data multiplicand must be initially in M. So you clear that A, add A with M, store the temporary answer in A. Again, decrement your B. So after completing one addition, decrement B. Now B becomes 1. Again, since it is not 0, go and add 4 plus 4 is 8. Again decrement b. 1 will become 0. So since it is 0, come out and store the result. This is how you do your multiplication.